Today also we are able to do another class again, mashallah. Alhamdulillah Rabbil Alamin. We should always say thank Allah subhanahu wa ta'ala, you know. That's why Allah subhanahu wa ta'ala, if you thank me, I give you more. Wala in shakartum la ajidannakum. Yes. So the topic we are doing today is compound interest. To be candid, when I was doing it myself, I had difficulty. So it's after I look at many books. And that's what a good student should do. Whatever you are doing in class, you don't understand, go to textbooks. Our time, we don't even have good textbooks. Okay? We have to go and borrow from people. No, it wasn't easy. So you go to textbook and look at the topic you are doing. If you are doing thermodynamic reactions, okay? Endothermic and exothermic reactions. Yeah? Go textbook and look at exothermic and endothermic reaction. If you're doing compound interest, after you do a class, before you go to bed, take a textbook and look at compound interest and try to do some questions in it. That's how you become more proficient. Okay? A student who is astute in learning, who is strong in learning, he is not satisfied with what the teacher teaches in the class. He go and investigate himself. That he become a top student. No one is stupid. They say black people are lazy in their brain, yeah? But my own philosophy is no one is stupid. Your stupidity depends on your laziness, okay? If you are lazy, you'll be stupid. But if you are very hardworking, you will not be stupid. And when exam comes, it makes difference, yeah? Well, divine providence, you know what is called divine providence in English? Destiny, what Allah destined for a person, yes? The intervention of divine providence sometimes marks the reality of situations. A person can work hard and yet he die early, or he cannot achieve what he wants, yeah? But on the whole, Allah connect hard work and results. That's why he said to Rasulullah, Fasbir ala ma yaqulun. Wa hajruhum hajran jamila. Leave what they say. They castigate you, leave that. You concentrate on what I ask you to do. Okay? Make patient, because patient will produce the results. So if you work hard, always if you work hard, Allah subhanahu wa ta'ala will provide for you. That's why Allah also said after Iman, he doesn't stop there. Say, wa amilu salihat. Innal ladhina amanu wa amilu salihat. Those who work hard, those who work good, those who believe and then work good. So that's why I always said, if you want to succeed in life, you must work hard. You know, so that we all disprove this philosophy of black people are lazy. You know, their brains are lazy, they don't think. Okay? So, compound interest. We look at simple interest, where there's a constant application of the interest rate on the principal, not on anything else. But compound interest is different. Let me draw my bank and human person analogy. That is the bank, and that is the person. Yes, you send the bank your deposit. They give you loan. Okay, and they charge on you interest. Either interest received or interest paid. Now, for simple interest, when you put £200 at 10% for 4 years, yes, for 4 years, every year the interest is charged on the principal, yes, the 200 in it. So you earn £20, £20, £20, £20. Now compound interest, because the bank is assuming you are going to withdraw some of this money. You get it? But for compound interest, they assume you are going to leave this money there and the interest that you gained previous year. Okay? So the interest is calculated on the amount plus the interest in it. Let's see how it goes practically, yes, step by step. Okay, now I'm going to speak to you like I will speak to university graduates, okay? Not like my broken Gambian English. even Gambian, even your professors here, we still like to speak in our, just like Nigerians, even their professors here, they still speak in their own dialect, okay? Yes. Now, look at what I'm portraying here. Now imagine this guy put 2,000. Yes. Again, we are using our 200 deposit. Okay. Rate of how much? 10%. A number of years of 4. Okay. That's what we are using. Okay. Now, let's say rate 10%. Okay, we put our calculation here, or maybe calculation, or we call calculation, yes. Okay, so I have to rub that, please. And then the interest, okay, the interest and the compound amount, okay, compound amount, or the accumulated amount, yes. The accumulated amount. Okay. Now, first year 1, year 2, year 3, year 4. Now, first year we get how much? 10% of this in it. 20. Okay. Let's say 200 times 0.1. Yes. 10% is 0.1 in decimal in it. How much am I going to earn? Yes? How much am I going to earn? No, 20 pounds, yes? Interest, yes? So let me put this calculation and interest. Okay. Now, how much am I going to have in the bank now after 1 year? I mean end of year, yes? Remember, this is end of year, yes? So after year 1, I'm going to have 220 pounds plus the 200 in the beginning. I'm going to have 220 pounds. Okay, as an accountant, we do it like that. Put our pound sign up. That we are dealing with pounds. Okay? Year 2, who can predict what we're going to get?
Another 20 pounds is 240.
No, you see, let me didn't get my explanation. That means you guys didn't understand what I was saying. Okay?
Oh, so
I'm saying simple interest, you calculate the interest constantly on the original amount every year. That's why we did it. Can you put that down, please, for a moment, and put all your mind here? Okay? In the compound interest, even the interest is charged on the interest before. Previous year, yes? So this year, you're going to say 220, which was the cumulative, times 0.1. So the interest will be 22 pounds in it. So the cumulative amount will be 242, in it? Yes. Do you see how it goes? Compound interest, yes? It's different from simple interest. Simple interest, you have been 200 times 0.1, 200, 0. Until we finish. Now the third year, what's going to happen?
That is 0.1 times 4.
242 times 0. Remember, 0.1 is the interest rate. And this is 10%. 10% over 100 is how we got 0.1, in it? Yes.
24.2.
So we are going to get 24.2, and we add 24.2 to this is how much?
46 pounds.
246.2. Now that is end of year 3. Year 4, what's going to happen? 246 times 2 times 0.1, which is the interest. Okay? So basically I'm finding interest 10% of
24 pounds.
Of 246.2. That's what I'm doing here. But instead of saying percentage, you just convert that percentage into decimal, in it? Yes. So that will be how much? How many percent? How much?
4.62. 24 pounds. Oh, no.
Are you, no? Times 10%, yeah? 24.62, in it?
Yeah. That one, it should be 286.
That one, this one?
Yeah.
Remember,
it was 242. They added 24, so it's 286.
No, you have 24 here. Yes, so that's correct. Okay, so again, it will be what now? Add this to that. You need calculators, you know? 26 or 270.82, yes?
Did I look?
6 years? 0.2.
Yeah.
So this one will be 266.2 times 0.1, it will be
26.62.
26.62. So if you add it to that one, it will be how much?
Add 2.2. It's 292.82.
292.
0.82.
Now this is what you call compound interest, okay? It's different from the simple interest. Huh? You get it? Now, what do you observe from year to year? We are multiplying by 0.1 in it. So it means we multiply 0.1 and we add that onto this in it. 0.1 we add that onto it in it. So this is there was a previous. Now you get that, yeah? Let me expand this, okay? That means there was a previous. It's like 200. We multiply by 0.1 in it. Yeah. So we multiply that also by 0.1 in it. Okay? Do you get it? Yes? We multiply by 0.1. The other next year also multiply 0.1 because we multiply by 0.1, 0.1, 0.1, 0.1. Do you get what I'm saying? Yeah. Okay. So therefore, this is long mathematics. But a smart mathematics, a smart person with a smart brain will quickly observe that we don't need to go through all this long calculation. You don't need to go through all this long calculation. Year 1, year 2, year 3, year 4. First year, what we did was we multiplied 200 by 0.1. Now, if we wanted to add the 200, mathematically, we are going to say that 200 times 1.1. Do you get what I'm saying? Because after we got the interest, which is 200, yeah. 200, yes. 200. Because when you get 20 pounds here, the interest, we are going to add it into the 200 in it. So it will have been our cumulative plus 20 in it. And 20 was in it. What we are going to have here, we are going to say our 200 we get plus the interest in it. Plus the interest. And the interest was 200 times 0.1 in it. Now mathematically, what do you see? If somebody asks you to factorize this in it. If somebody asks you to factorize, you're going to say 200 into 1 plus 0.1 because 200 in both sides, in it. Are you following me? Yes. So 1 plus 0.1 is 200 into 1.1. That will exactly give you 220 in it. So in the following year also, you are going to do the same thing in it. Yes. The following year, we are going to multiply this by 0.1 in it. And we add a previous one in it. Yes. So if you want to put it in mathematical context, you are going to say, look, I don't need all this long thing, yeah? What I am going to do is, what I'm going to earn at the end of the day, I'm going to say 200 times the multiplier. And the multiplier is the interest. They call it 1 plus R. I'll show you in the formula. That's why the formula for compound interest is P into 1 plus R to power N. R is the rate of interest, which we normally divide by 100. The one is because the principal, if you want to add the interest into the principal, like what I demonstrated, how they got it, is 1 plus 0. The rate of interest in it. N is the number of years in it. Because year 1, we multiply 1.1 at 1 because it's year 1 yet, and we get 220. We get 220. If you have any doubt, please tell me before we proceed. But year 2, guess what? This amount, I'm going to multiply by another 1.1 in it. Yeah. So I'm going to say 220 into 1.1 times 1.1 again, another one, because I'm going to add them again. So instead of doing that, because it's 1.1 times n, it's just like saying 200 into x times x, in it. That will be 220 squared, in it. 220 times x squared. Now we put a 1.1 in that place, yes? We are going to pay is year 2, after year 2 is going to be 200 times 1.1 square. Okay? And square is our n because year 2. You get it? Okay? Year 3, we are going to get 200 again times 1.1 to year 3 for now. Year 4, we are going to get 200 times 1.1 to year 4. Instead of saying 1.1 times 1.1 times 1.1 for year 3 and 1.1 times 1.1 times 1.1 for year 4, we put it in form of index. Okay, indices, yes? Because x times x times x times x is x to the power 4. That's why we got the 4 there. Now, that's what the intelligent put the formula for compound interest. Instead of the previous one, we calculate, we add, we calculate, we add, we calculate, add. We find the cumulative every time. The formula of compound interest, that means the amount you get at the end of the year is P into 1 plus R to the power n, where R is rate of interest, okay? Rate divided by 100. That's what we do. 0.10% we calculate in decimal, and n is equal to number of years as in our simple interest, in it. As in simple interest, we derive a formula, isn't it? Now, compound interest also, we derive a formula. Okay. Do you get it? Yes. And this is the quickest way. Now, let us try our formula and see whether it will work. Remember, we got 292 plus something, yes? In the first one, yes? So let's see. The amount at the end of the year you'll get is going to be P into 1 plus R to the power n. And the interest rate is how many percent? 10% for 4 years, in it. So 200 into 1 plus 0.1 to the power 4. 4 years, in it. That'll be 200. 200 into 1.1 to the power 4. Now, what is 1.1 to the power 4? It means 1.1 times 1.1 times 1.1 times 1.1, yes? And you go to 121 times 121, yeah? You have to use the calculator now. This is called compound interest, yes? So we end up with 200 into 1.4641, okay? So I multiply that 200 times 1.4641. How much is that? We should end up getting this. Exactly, we got the same thing in it. Please look at the way I'm presenting my work, yes? Neatly, yes? You can see step by step. Now, if I give you some work to do, I expect you to do exactly the same. Okay? Step by step, not one hanging up here, there in the air, one there. So we proved that correct, innit? Okay? Now let's see, how much was it? 292.82. 0.82, okay. Now, that's what we got, yes? Now let's just pretend that we don't know the R. Okay? But we know how much we get at the end of the year is 292. So A is equal, always put the principal 1 plus R to the power n. Always put your formula in it. So for A, we got 292 in it. Okay. We got 292 in it. Okay, 0.82. 82 is equal to 200, 1 plus R to the power n. Now what we don't know is, we don't know what R is in it. We don't know what R is, yes? This is n. So we are trying to find what R is. Now, if you are a smart mathematician, you would have arranged, although we have not done arrangement of formula. Yes, but we could have done that, yes? Because we are going to say P into 1 plus R to power n is equal to A. A means how much you earn after, how much be in the account after 4 years, isn't it? That's what you call the egg, okay? The egg. In pension terms, yeah, you call it the egg. The amount that will be in the account after the number of years, yes? Now, 1 plus R around to power n, we move P over the equal sign, become dividing it. A over P in it. We're going to do all this in mathematics when we do algebra. Okay? Now, remember we have n here. Yes. Now to power n, we have to power n here. Okay? Like if I tell you x square is equal to 4. Okay? X then is equal to the square root of, okay, or 4 to power half, yes? So if you want to do it in mathematics, you're going to say 4 to power 1 over n. Okay? So that will be the next step, yeah? I don't know whether you get me. If I tell x to power 1/3, x cubed is equal to 27. So what is x? X will be, is multiply here, it divide in next sign, is to power 27 to power 1 over 3. Same way, if I ask you, x to power 4 is equal to 64, 4 to power 1 over 4. Multiplication here, indices here, multiplication but division the other side, isn't it? Yes. I can understand it's difficult for you, yes? Okay. It's difficult for you, so, but when we do algebra, you will come to know all this, yeah? Now, that is here, 1 plus R. I know if students are having difficulty, you can see from their eyes, 1 over n. Okay? But R alone is equal to A to power P, power 1 over n, minus 1. You look like Chinese, isn't it?
Yes.
Okay then, let's leave that one, yeah? Let's concentrate on here. Yeah, you're going to understand. In fact, it is even more difficult when you ask find n. Okay? Then you even find the logarithm of, yeah? I don't think they'll give you n to find out n the GCSE. No, they will not. The simple thing is they will ask to find how much so a trial and error, yeah. Yeah. So I don't expect them to be asked that much to ask you to find n, the number of years. Okay? So even they happen, as Halima said, you can do trial and error. Okay? Put 2 here and see, put 3 there and see, put 4 there and see. So if you put 2 and 5, okay? If you put it will be lower, you put 5, it will be higher. So the answer lies between 2 and 5 in it. Yeah. Yeah, that's right. What do you call that in English, in math term?
Boundaries.
No. It's not approximation, yes, but there's something called trial and error. Yeah. There you are. So mathematically we come here. For our this one, we know this is 4 years, isn't it? This is 4 years, yes? Okay. Now, if you want to get rid of 200 here, what do we do?
Times both sides by 200. Times both sides by 200.
No. What do you do?
Divide both sides by 200.
Divide both sides by 200. Yeah. Are you stuck in it? Yeah. Don't be ashamed. Look, you have to practice, yes? We have not done algebra, but this is algebra, okay? To get rid of the 200 here, we divide both sides by 200. We say we move 200 over the equal sign. It is times here, I become divide here in it. Yes. Yes? But for this side, let's put the equation the other way, yes? This side we get 1 plus R to power 4 in it. This are how much, what do we get? 292.8 divided by 200. How much do we get?
1.46.
1.4641. 4641. Okay. Good. Good. Now, I show you some mathematics in it. If you said x to the power 3 is equal to 27, x is equal to what?
27.
1/3 of 27 to the power 1/3 or cube root of 27, because 1/3 it means cube root, isn't it? Yes. Okay. So basically, when we move this over equal sign, it becomes 1.4641 to the power 1/4, which is 4th root, is equal to 1 plus r. Okay, so we eliminate the indices, yes? We eliminate the indices, yes? Okay. Now, what is the 4th root of 1.46? Can you give that element now? I know you can do that. Find the 4th root of, is 1.1 is equal to 1 plus r. What do you guys see? What will be r? R will be 1.1 minus 1 is equal to r. So therefore, r is equal to 0.1. And if you convert that into percentages, what do you do? Multiply by 100, and that's equal to how much? 10%. Are we not back to 10%?
Yeah.
Yes. This is called compound interest. Yes. We are going to do a lot of work in this, so don't be scared. Yeah. We're going to do a lot of examples in this. You'll see.
27.
Compound interest, because it seems these guys don't understand still. How do we get back our £100? Our 100. How do we get our 200? How much will you invest now? How much will you invest now? How much will you invest now? Now, at interest rate of 10% for 4 years, okay, to get 292.4 in your account, okay? In your account. But
292.8.
yes, 292. But they said they will interest rate, or they will say at compound interest rate. Yeah, they make it clear as compound interest. Yes, rate of this to get 90. That means how much do I invest now to get £292? Because this is what you do in pensions. A person thinks that when he retired, he needs $2 million to be pound in his account. How much must he put in a pension fund, which is earning him 10% interest, to get 2 million at the end of certain number of years? He's going to retire when he's 65. He's now 40. So 25 years time, how much should he be putting in the bank now at that interest rate guaranteed by the bank for him to earn £292 or £2 million in the next 25 years? Okay, the banks use this and they call it APRC. We are using monthly interest, yearly interest rate, but they use annual interest rate. Yes? Okay? Okay. Now we know what we get at the end of the year is going to be the amount we deposit now into 1 plus r to the power n. That's what we know. But we know we want to get £292 at the end of the year, innit? So the amount we deposit now we don't know, but we know it's going to be at 10%. Yes, 10% yes, 0.1 in it. 1 plus 0.1 into 4 years, because it's going to after 4 years in it. So this is 292.8 is equal to P into 1.1 to the power 4. Now, okay. Now, before we do therefore, P alone, to get P, we have divide this by that in it. Okay? So P is equal to 292.8 divided by 1.1 to the power 4. And that is equal to 200 pounds. Yes. Shall we leave this topic until we do algebra? Because I'm reading from your faces that this looks like Chinese to you. I shouldn't be like Chinese. I'm just applying formula and put figures in it. Once you know this formula is memorized. I think it comes, they give it in an exam. Yes. This is the formula, and you must know its ingredients. A is what you earn after so many years. P is what you put in now. R is the rate of interest. And N is the number of years the money is going to be in the account. Do you get me? Yeah. Yes. Do you have any math book here? We look at a question on compound interest. Now I got a question, a GCSE question. I want us to deal with it, yes, to demonstrate whether you understand it or not. Okay. This big book is the 1 to 2. Okay. John invests 2,500 for 2 years at the interest of compound interest of 4.2 per annum interest. Work out the total amount he gets after 2 years. Okay. So here, John invests 2,500 pounds in an account at compound interest, yes, compound interest of 4%, yes. I don't want to put a big amount, 4%, yes, 4% for 2 years, yes. How much? Number one, how much will he get in the account? In the account in 2 years, yes? And number two, in 4 years. Okay, let's say 5 years. 5 years. Now we are going to do all of them. We have to identify in the questions what they actually want. I mean, first of all, you put the formula. What is P?
P is the
Principal. The principal, yes. The amount he invests now. What is R?
The rate.
The rate of interest, yes. But rate of interest in
Or in this case, 10%.
Yes. 4%, yes. But rate of interest in decimal terms, yes. And what is N? Number of years. But here, can we put that in our formula? When we put that in our formula, it will look like this. A, which you don't know, because that's what he asked us to find. How much you earn after 2 years, in it. Our P is 2,500, in it. Yes. Into 1 plus, what is our R? 4%, yes? 4% in decimal is what? 0.4. And how many years?
2 years.
2 years. This means after year 2, it. So basically, you got everything. Yes? A is equal to 2,500 times 1.04. Am I right? Yes? It's not 1.4, it's 1.04. Okay? You guys got that wrong here. 0.04 to power 2. So 1.04 to power 2 means 1.04 times 1.04, in it. Yes? So this equals to 2,500 times what? 1.4 times 4, 16, yes? 1 point what? Tell me, don't jump the gun. What is the multiplier? This is called the multiplier, okay? They can ask you what is the multiplier. The multiplier will be what happened here. This is called the multiplier. Remember, this is the multiplier. Here, the multiplier is 1.04 to power 2.
Equals to 1.08.
1.0816. So you multiply by 2,500. What do you get? Look at the way I am trying to work methodically. Okay, my work is systematic. It is methodical. Okay, so that's how much?
Times 2,500. 2,704.
Exactly. They can change this and said, if he earns 2,404 in the second year, how much must he invest? Then you don't know this, but you know that, innit? Yeah. Okay. Now look at the second one, number 2. Number 2 basically is the same. We just slot in our figures in it. 2,500 into 1.04, this time to power?
3.
No?
4. Oh,
No?
5.
How many years?
Oh, 5.
5 years.
That was 2.
No, 5 years, please. That is A. So this basically this is 2,500 is equal to times 1 point what? What is 1.04 to power 5?
It is
You have to get a scientific calculator.
1.
Two of you, yeah?
That is long. It's 1.2166. 1.22 basically, yeah.
So you multiply that by 2,500, how much do you get?
Actually, it's 1.21.
Hmm?
You can't round it up though.
Subhanallah, Jadeen. I'm refreshing myself. Oh, it's tiring. Yes. Then we put another video, okay? Okay, subhanallah.